And yeah, welcome everyone to this webinar series. As Edison has already said most of the things, I'll keep my introduction very short. So my name is Michael. I'm a data scientist and I have worked as a data scientist for about 4 years now. A data scientist, for those of you who might not know, is basically a person who is trying to analyze data to gain some insights from it. So I did work as a data scientist from 2016 to 2018 for a consulting company in Germany. And since then I'm doing the same thing, but as a freelance. Just to give you an example of what we did with my old company, for instance, we would be contacted by a supermarket retailer chain who would say, hey, we have all of this past sales data. Can you write an algorithm to predict how many tomatoes I'm going to sell tomorrow in Berlin downtown supermarket XYZ? So we did a lot of implementation things, but also, especially for the companies who weren't that advanced with data science, machine learning, we also did a lot of strategy consulting, meaning we told them, hey, in your field of business, this are the main competitors and you can gain an edge by using this and this data. And for that, you need to start collecting this and this data with this tools and these infrastructures. I have also written a book about these things because one thing I did, or we as a company also realized, is that data science, machine learning, artificial intelligence, big data, predictive analytics is an area, a field where there's a lot of buzzwords flying around, but no one really knows what all of them mean. And so I co-authored a book with 2 other authors in the past 2 years, which is called The Ultimate Data and AI Guide, where we try to, give clarity and bring clarity to all of these buzzwords and help everyone leverage data and innovate their business with data and everything that is associated with it. If you want to find out more, I have a webpage. You're also more than invited to connect with me on LinkedIn. These are the links for that. Good. So I'm very glad that everyone is here, people from all over the world. This is very exciting. So let me flip to the question of what we're going to cover today. And not only today, but also over the course of this series. So this webinar series consists of 5 parts. And today we have part 1, which is concerned with digital transformation and big data. And as you'll see, in general, in principle, you should be able to join meeting 3 if you, for instance, skipped meeting 2. But I would recommend that you attend all of the meetings because they are interlocked and intertwined in a way. And as you'll see, we start with the broader picture and start with the questions of why and what. So why is data important? What can be done with it? What is artificial intelligence? What is data analytics? Why do companies who use data analytics have a competitive edge? 2 more how questions. So how can you as a company start using data? How can you start collecting data? How do you implement data use cases? We'll look into more of these things towards the end of the webinar series. So today in part 1, we look at digital transformation and big data. Next week, we're going to be looking at what we can do with data. So we're going to be looking at data analytics. We have a short detour into the cloud and job roles, just to make sure that everyone is on the same page and also understands what is that and what can be done with it. In the 3rd session on the 12th of August, we're going to be looking into machine learning and AI. So see what it is, what it can do, what it cannot do, what it can also maybe do for your company. And then the last 2 sessions are really dedicated to help you with your company to first, in the 4th session, see what a data strategy is and how you can create one for yourself. And in the last session, we're going to be looking at, once you have a data strategy laid out, how do I execute it? And we're going to be looking at a few examples. Edison has already mentioned it. If you have questions today along the way, feel free to post them in the chat. I think that's how you meant it, Edison. And I'll try to leave some space towards the end, the last 5 or 10 minutes, so we can address these questions you might have. So the overall learning objectives of this webinar series is that the first one we're going to be looking at today, which is develop a data-driven thinking and apply it to your business. This is really the main thing I want everyone to get out of the meeting today, that you basically start changing your mindset and develop a data-driven mindset and thinking. Then also over the course of this webinar series, you'll learn what the most important buzzwords are and how they relate to each other. So I just want to give everyone clarity on these things. You will discover how you can leverage data in your company to achieve your business goals. That's what we're going to be looking at towards the end. And with that, also develop your own data strategy and learn how to execute it. Good. So that's the bigger picture. Let's look at what we're going to be seeing today. Today, we're going to be focusing on 3 topics. The first one is digital transformation, which is basically answering the big why question. Why is everyone talking about data now? Why is AI becoming so important? Why is there so much confusion around it? And why must or should companies embrace data and everything that has to do with it? Then we're going to be looking at, in the second part, at big data. What is it? Where does it come from? And how is it going to develop, basically? And in the last bit, we'll have a short section of practical advice and what all of this means for you. And I'll share some tips on how you can become more data-driven and show some examples of what it means to be data-driven. On the left of the slides, I have the roadmap so that you don't get lost and see where we are in the big picture all the time. Good. So let's start with the first section, which is the big why, digital transformation. When a snake sheds its skin, it changes. When a caterpillar becomes a butterfly, it transforms. Cool. I like to start with this slide, which shows the 10 most valuable companies in the world in the year 2000 and in the year 2010. And the main thing I would like you to get out of this slide is that in 2000, you'll see that it's a very broad mix of companies that made up the most successful companies. So General Electric, which is an electrical company, telecommunications, Exxon, oil company, but you also have Pfizer, which is medical company. So it was a very, wild mix. By 2010, the picture had changed a bit already. And actually what you see is that the 10 most valuable companies are mostly dominated by oil companies. So you have Exxon, you have PetroChina, BHP, Petrobras, Royal Dutch Shell. So really oil companies were the richest one, let's say. In 2020, things had reshuffled significantly. And some of you might know, today, the most valuable companies are Apple, Microsoft, Google, which is Alphabet, Amazon, Facebook, Alibaba, and others. And, what you see is that there's a pattern. And this pattern, I've shaded in blue, is that the most valuable companies have a few things in common. One is they're tech companies. 2 is they're either based in the US or in China. So Tencent and Alibaba in China, and the rest is in the States, in the Silicon Valley. And 3, all of these companies are very data-driven and are somehow disruptors in their field. So this is really an example of digital transformation. We see that companies who embrace data are disrupting their sectors and are becoming successful. This overall trend of digital transformation basically means that as a company today, you must innovate or you die. And this graph is showing this because it's showing data of the average lifespan of a company in the S&P index in the United States. So it's not the Dow Jones, it's the S&P, which consists of 500 companies. And in 1960, the average age of a company in there was 60 years. But by 2010, the average age of a company in the S&P index had decreased to 20 years. So if you want to put it differently, it means that once you enter the S&P index as a company, you have about 20 years until you die and you're being disrupted away by some company who is embracing digital transformation, who is driving digital transformation. This trend is going to continue even further, and it's projected to reach the average lifespan of a company in the S&P index is expected to reach a mere 12 years by the year 2028. And to give you an example of how digital disruption or transformation looks like, I like showing Netflix, which I guess most of you will be familiar with. What probably most of you don't know is that Netflix had a very similar business model to its main competitor back then, which was Blockbuster. Blockbuster was an American company who basically rented DVDs and movies. So you could go to the store and rent a DVD. That was back in the days. For those of you who still remember, or you could also hand DVDs or movies sent to you in a package via post. And Netflix had the exact same business model. They also rented out movies and DVDs as physical discs. But what happened in 2007 is that Netflix had a breakdown of a database, and that made them realize that their business is very vulnerable. And so they decided to change their business model to the business model as we know it today, which is not sending DVDs physically as renting them, but creating and establishing a streaming platform where users can stream movies on demand. And from 2007, what we see is that Netflix is continuing to rise in its market value, and Blockbuster has gone bankrupt in the meantime. So what this story shows is that you know, it wouldn't have been enough for Blockbuster to become more cost efficient or save costs or sell more DVDs. It shows that in order to survive, Blockbuster would have had to really transform its business model like Netflix did. And so because it hasn't done that, it has been disrupted away by Netflix and is now bankrupt. So when we're talking about the big why, digital transformation is the answer, because if you don't innovate and if you don't include innovations in your business model, you're going to lose your competitive edge. Now, digital disruption or transformation is happening in every industry. And we had this short survey. I saw that there's a lot of people in the tourism industry, agriculture industry, there was also textile industry, IT industry. Wherever you look, there is digital transformation or disruption going on because innovation is in every sector, right? And so this is a few examples of, you know, Airbnb has basically completely transformed or disrupted the entire hospitality industry and is today, I think, worth more than Marriott and all the other major hotel chains. We see the same thing happening with Tesla in the automotive, with Netflix entertainment, and also with Uber and transportation. And you can basically name any sector and you'll see that there's going to be some disruptors who are changing the rules of the game. Good. So digital disruption means, you know, the rules of the game change in an industry, but where does it come from? And the answer to that is that for a long time, digital transformation has been driven by what is called digitisation and digitalisation, which are two slightly different things. Digitisation means simply turning analog into digital. So it means, for example, turning VHS cassettes into MP4, or it means turning a CD into MP3, or it means turning a postcard or a letter into email, or it means turning an analog picture into your picture that you can store on your smartphone. So it really only means turning analog stuff into digital stuff. Digitalisation, which is a bit a broader concept, refers to restructuring business processes or processes in general around digitization. So for example, if I go to the doctor, I used to get a letter saying, okay, this is your diagnosis, but at least in Germany now, I can also just get it via email. You know, sharing of videos, anything like the way we communicate with email instead of letter, the fact that I can sign things and scan them and send them to someone, this is referring to digitalization. So making use of the fact that we can digitize things and restructuring business processes around that. Also, the webinar we have today is obviously one example of that. And digital transformation is really all the changes that happen on a broader scale within a certain sector or even the economy or even the entire society that come through all the digitalization processes that we see in different sectors. And so this is basically the sum of all of these things. This is where digital transformation came from historically in the past years. But today what we see is that the source or the main driver of digital transformation is actually shifting. And to see that, I have put on this slide again, which again shows the most valuable companies in 2020. And I guess if I asked, so I like giving presentations in person because now I could simply ask who has today used the Google service already, who has used the Facebook service, including WhatsApp today, or maybe WeChat, which is the app which is developed by the company called Tencent, a Chinese company. And I'm pretty sure that about 99% of the entire audience here would raise their hand. And if I ask the question, who has ever paid Google, Facebook, or Tencent to use their services, I'm sure that only about 5 or 10% of all the hands would go up. So this is strange, right? Because on the one hand, these companies have become the most valuable in the world. Yet on the other hand, they somehow manage to not charge for their services. And the reason or the missing piece in this puzzle is, and this is also the thing that is driving digital transformation increasingly, is data. So what these companies have really managed to do is that you don't pay these companies with a monetary value, you pay these companies with your data. And these companies collect huge data assets. They have today the most valuable data assets in the world and somehow manage to monetize them in a different way. Google does a lot with advertisements, so does Facebook, and Tencent is using a few different revenue streams. So what we're seeing is that the main driver of digital transformation is shifting. It's shifting away from simply digitization and the digitalization of business processes towards using data and using everything that can be done with data. And we'll see in this course that it's a lot. And most notably, the thing you can do with data is data analytics and creating AI systems. So computer systems that perform a task for you. And yeah, the possibilities that digitalization offer is still very large, the potential for many industries and for a lot of companies. But at the same time, they're increasingly also exhausted. And so really data is going to be the new driver of digital transformation. I've just mentioned it. One of the cool things you can do if you have a lot of data is that you can create artificial intelligence, so AI systems. And we'll talk about this more in part 3 of this webinar series. But in a nutshell, AI are computer systems that display a degree of intelligence and that are therefore able to perform tasks that would usually require human intelligence. For example, I am currently working on building an AI system which is able to transcribe text automatically. So I'm developing a web app where you can simply, for instance, upload this audio file of this Zoom meeting. And what you would get back is a transcript of it. So a written version of everything that has been said. And this is one example of an AI system, which is able to perform the task, listen to an audio and write down what is being said. And there's many, many more examples, and it's really at times amazing, at times also a bit scary and daunting what can be done with AI. But yeah, we'll look more into this in part 3 of this webinar series. So the digital transformation that we're seeing right now And the use of artificial intelligence, which is driven by data, is often compared to the Industrial Revolution or industrial revolutions that happened since the 18th century. And these industrial revolutions are often said to have equipped us with muscle power. So just think of the steam engine and think of everything that is being done today with electricity and with oil. And think of all the machinery in production. Think of in the textile industry, the fact that a lot of machines help you produce things. In the agricultural industry, think of all the tractors and everything and all the machines that help you there. Basically, all of these machines have equipped us with muscle power, and they have taken off of our shoulders the heavy elbow and grease work, or a lot of it at least. And so these machines are driven by motors, right? They work with motors. And for motors or steam engines to work, what they need is oil. And so oil, up until today, actually is the main resource that is running our economy, or has been in the past. The development that we see today with digital transformation is very, very, very similar, but it works with different parameters. So it is often said that artificial intelligence is equipping us with mind power, because now these AI systems aren't able, I mean, they will also be able to take off physical labor off of our shoulders, but these AI systems actually mostly taking tasks that require cognitive abilities off of our shoulders. And so this is often called mind power. So what we've seen in the past a few hundred years is that a lot of jobs that were related to physical labor have been automated and have been disrupted away. What we're going to see in the next decades to come is that a lot of tasks that require some sort of human intelligence, some mind power, some cognitive abilities are going to be automated and disrupted away by artificial intelligence. For instance, someone who transcribes this audio into a text. Now, as we'll see, the way to create such AI systems and the way why data is becoming so important is because to create such AI systems, you need data. The more, the better. The better quality, also the better. So yeah, AI is basically leading to mind power, or it's equipping us with mind power. And so just to give you a few examples of how digital transformation in the past has been driven mostly by digitization and digitalisation, and how it will be driven more by the use of AI and the use of data analytics and data. And this is a table to show you that really it's affecting every industry. So for example, if we look at the retail industry, if we look at Amazon, digital transformation 20 years ago meant that you can buy products online rather than having to go to a physical store. And that's amazing, that's great. But once you have done that, what's next? And the answer could be, for example, is that online stores anticipate customer needs and preferences, and they show relevant product recommendations to their customers even before they know that they want a product. And so Amazon, for those who visited or know the store, they do that already. If you click on a product there, they say, hey, this product is often being bought together with this product. So for example, sunglasses are often being bought with sunglasses case. Don't you also want to buy the case? By the way, if you do it right now, you get 5% discount or something like that. We have something similar in the insurance industry, you know. 20 years ago, digital transformation or disruption meant that you can apply for insurance policies online rather than having to send in a printed and hand-signed form. But in the future, once we have that, what's next? It could be, for instance, that we automate this process by having an AI system assess insurance applications so that insurance companies save costs and customers can have their application reviewed much faster and with a much higher accuracy. And really, we see, you can name any industry and there'll be an example of how digital transformation was driven by digitization 20 years ago, 30 or 10 years ago. But once we have that, the next thing will be embracing AI. I'll leave out the other examples so that we can move on to data. Good. So quick recap. What have we looked at so far? So digital transformation is basically the big why. It means that you need to innovate and you must innovate to stay competitive. It was previously enough to digitalize your processes, but increasingly innovation must also necessarily tap into using data, for instance, by creating AI systems. Good. So let's look at data and let's look at big data. Data is the oil, some say the gold of the 21st century, the raw material that our economies, societies, and democracies are increasingly being built on. This is a quote by Joe Kaeser, who is the CEO of Siemens, which is one of the biggest German companies in the telecommunications sector. So if data is so important because it's driving AI, let's be very clear on what data is. And the way I like to think about it is that we have something which is called the real world, right? Which is somehow the sum of all facts, like the fact that I'm called Michael, like the fact that we're currently having a webinar, like any other fact. And really what data is trying to do is trying to represent these facts and store this information in some sort of digital form. So the fact is that my name is Michael, and when I just signed up for this webinar, I needed to enter my data into a form, right? I've obviously put my first name, but I could have also had a typo in when I typed my name. And so this data, which is supposed to represent my name and supposed to represent the fact of my name, might be valid or might not be valid. So there's a difference in data and facts because data is not always necessarily valid. That's an important point to mention, especially when we talk about data quality. So yeah, really you can think of data as simply being information stored in digital format. And this is important because once we have it in the digital form, we can start harnessing it and analyzing it with computers. There are different types of data, and there's even different dimensions along which we can distinguish data. Some of you might, from school or from university, still remember that there's a difference between qualitative and quantitative data. There is, for those who are in the IT sector, a difference between transactional data and master data. But really the most important distinction that can be made to classify data is its degree of organization. And in that regard, we distinguish between three different types of data: structured data, semi-structured data, and unstructured data. And structured data is basically any sort of data that has a high degree of organization with a specific format. And it's always structured in a spreadsheet-like manner. So an example, and really what I want you to think of if you hear structured data, is an Excel sheet which contains data structured in different columns. You know, column first name, column last name, column birth year, column location, etc. This is structured data. It can also be stored in a CSV or in, you know, what is called database. But yeah, in its most simple form, it's simply stored as an Excel. On the other hand, we have unstructured data, which is basically information that has no predefined organizational manner or no specific structure that it follows. And really, unstructured data is every sort of data that is not structured. And it can take a lot of forms. What all of these forms have in common is that they're typically very easy to consume for us humans, but they're very difficult to make sense of for a computer. So we have videos, we have pictures, we have text documents, we have emails, we have PDF documents, really anything that is not structured data. And the problem with unstructured data is that it's difficult to analyze it, though right now we're making a lot of progress within this area. And it's difficult to analyze it because it's difficult for a machine to make sense of it. To give you an example, let's say I had a list of the 126 participants we have in this webinar right now as an Excel list. Then I could simply filter, hey, I want to find Edison in that list, right? And machine would be able to do that for me. However, if I had a picture of all of us, I could not simply tell a machine, hey, computer, please look for Edison in that picture. It's very easy for us humans, but it's very difficult for a machine. And so this distinction between structured and unstructured data is very important because it has a lot of implications for what you can do with it, how you store data, and how easy it is to deal with it, really. Right, you have something in between, which is called semi-structured data. That's a bit more technical, but that's basically documents like JSON, like XML, also like HTML, so like website, that have a certain degree of organization and always follow a certain structure, but it's not as strict as structured data, and it's not as chaotic as unstructured data. Good, so that's the distinction.
Sorry, Michael.
Yes.
Can I just interject very quickly? Could you explain to everyone what's the difference between a relational and non-relational database?
Sure. Relational databases are all sorts of databases that store structured data, basically. So the way they work is that you can really think of chucking a few Excels in there and somehow interrelating them, so combining them. Non-relational databases are databases that are able to accommodate or store unstructured data. So yeah, we'll talk about this more in one of the other webinar series, but basically very simplified, you can think of relational databases store structured data, and non-relational databases are able to store unstructured data as well. Yeah, I hope that answers the question, Edison. One last note on this point. Question, does anyone know what the ratio of data in the world is today? How much of the data we have today is structured and how much is unstructured? I'll give you a second to think about it. But the answer is that we don't have any reliable data on this information. And we don't have any reliable data on this question, but estimates say that around 20% of the data is structured and 80% is unstructured. And yeah, structured data is obviously much more valuable because we can use it directly in analysis, whereas unstructured data is difficult to process. Good. So let's look at how data developed over time. This is a sheet that shows how much data we had globally in the year 1986 up until the year 2007. And it also shows of all of the information, sorry, I should say not data, but information, of all of the information that we had on this planet, how much of it was stored in analog form, so cassettes, books, vinyls, what else do we have? Paper, documents, and how much was stored in digital format. And what you see is that in 1986, around 2.6 exabytes were stored in analog format and only 0.02 exabytes were stored in digital format. So the ratio was 99.999% to almost nothing. In the year 2002, things had changed because we have created much more information as human race in the world. But also the shift of the way this information was stored changed. In 2002, we begin entering the digital age, meaning that we had 50% stored as analog form and 50% stored as digital form. And so since then, the share of digital format has increased steadily. So that in the year 2007, 280 exabytes were stored in digital format, so on hard drives, on CDs, on disks, on digital tape, and only 19 exabytes were stored in analog form. So this is why if back in the days a library or something burned down, this was a disaster for humankind, right? In the Middle Ages, or I don't know. Because the information, all of the knowledge that we as human race had created was stored in books. And so when a library burned down, that was a disaster. If something like that happens today, it's really no problem, because most of the information and knowledge that we have accumulated as human race is stored in digital format. It would be a disaster if, let's say, the internet was wiped out. But libraries we can bear. Good. So in 2007, the total amount of data we had in the world was around 200 exabytes. Note that this is 280 million, 280 million terabytes, which is, I think, terabytes is something that everyone can relate to. That's around one computer has around 1 terabyte of storage. Today, 13 years later, we have what is called big data. So it's not only data, but it's big data. And what does it mean? It's basically referring to data which is characterized by 3 V's. Volume, velocity, and variety. A lot of definitions also take in more V's. And personally, I'm not so much a fan of this definition because I think it leaves a lot of room for interpretation. But the alternative definition that I like would require more technical knowledge, and we don't have time to go into that. So let's stick with this simplified version. Big data is basically anything that is either very large, that is moving very fast, or that has a lot of different shapes or forms. And let's talk about the first point, which is volume. So you remember this graph that we just looked at with the analog and digital information that was 200 exabytes in 2007. By the year 2010, this had already been completely nullified, because on this graph, which shows how much data we have worldwide, the scale is not anymore exabytes, but zettabytes, which is 3 orders of magnitude higher. So it is projected, the data that we have in the world is projected to follow an exponential growth path. And we're supposed to have, by the year 2025, a total amount of data in the world of 175 zettabytes. So that's 175 billion terabytes. So this is what we mean with volume. Data is just coming in, it's being produced on an exponential basis. What do we mean with velocity? Velocity means that data needs to be processed much faster today than it has been traditionally. So this is a graph showing what happens every minute of the day in 2019. So this is actually outdated already. But just to give you an example, on the left bottom corner, you have Google, and Google conducts around 4.5 million search queries every minute. Just think about all of the computational resources that they have to index and go through their list of around 1.7 trillion web pages to give you the most relevant results. So this is what meant with this is what it's meant with velocity. We need process and results much faster. Variety means that traditionally we had most of the data stored in relational databases, which were invented in the 1960s. And so from the 1960s till up more or less until 2000, we had most of the data stored in relational databases by companies. Today, we have many more data resources and data sources, and the variety and the shape the data can take has also increased a lot. You know, we have all types of social media data, we have sensor data from cars, we have audio files, we have documents, we have websites, we have images. So remember the distinction between structured and unstructured data. A lot of these, or most of these new sources are unstructured data, and it makes it's quite difficult to process that and make sense of this unstructured data. Good. So we've seen what big data is. Where does it come from? There's a number of reasons, but really the 3 most important ones is that today we have a lot of sensors and data logging devices available. So especially in the production, in the IoT sector, Internet of Things sector, a lot of the machines are equipped with sensors that just track and create data every millisecond, every second, every minute of the day. And our computers and our websites are also one form of such a data logging device, because with these computers we can create data, who is logging into a website when, for example. So this is machine generated data, and it's been a main driver of data growth. Secondly, more on a societal level, we have a shift of our lives to the online world. So back in the days when I drove to a new city, I would stop, or my dad would stop, and I would, stop someone on the street when we were in the car and ask, hey, where's the cathedral in this city? And then this person would give me the instructions. You have to take the next right and then take the left, etc. Today, obviously, I ask Google Maps. Now, the big difference is that back in the days, the only one who had this information was the person and me, and it was not stored anywhere except maybe my brain. Today, the information of where I go, when I go there, how I get there is being tracked and is being recorded by Google Maps. And this live shift to the online world has happened everywhere. Just think about the things you buy. Before a couple of years ago, you would go to a store. Now you do it online. We used to talk in person. Now we have a recording of this webinar. So this is also, the shift to the online world has created a lot of data. And lastly, the fact that social media came up made every one of us a broadcaster. And so every one of us is creating tons of data simply by sharing their lives. Big data doesn't always mean big quality data. And this is an example of a Fictionary survey. And if you use data, and I'm sure many of you will be able to relate to this, if you have an Excel sheet, most of the time it looks something like this, with missing values, with inaccurate data, with formatting issues, with people typing in the wrong things. There's typos everywhere. And while we have this big data thing going on, and we can do a lot of things with big data, there's also a component that data must have a good quality so that we can work with it. And so one takeaway for you already is, if you want to embrace data and if you start collecting data, make the investment and ensure that its quality is high, or at least high enough so that you can use it. Data quality is also a very big topic that we would need to get deeper into. But for the sake of time, I would continue with this presentation at this point. Why is data quality important? Basically, in a nutshell, if you think about it, if you have some oil or some fuel for your car and it's just bad quality, so let's say you mix it with water, you're not going to come anywhere, right? You might have a Ferrari or a Mercedes or even a rocket shooting to the moon. But if your fuel quality is bad, then everything that it's supposed to drive is also going to be bad or dysfunctional. And the same thing basically also applies to data. If your data is great, you can create AI systems, you can create cool dashboards, you can do data analytics, you can do machine learning, you can do all sorts of things. But if it's of bad quality, you're not going to create any good AI systems, or you're not going to create any valuable or helpful data visualizations. So data quality is really important. Good. This is the last and third section of today. So we've looked at digital transformation. We've seen that we need to innovate. In the second section, we just now looked at data. We've seen that digital transformation is increasingly being driven by data, what the different types are and why it's important. And this last section is a very short one, and it's just meant to give you some practical advice so that you can become data-driven. Without data, you're just another person with an opinion. I love this quote by Edward Deming. So what does it mean to be data-driven? You might have heard of this buzzword also, and it's being used a lot. And I've said it before that Google and Amazon and Facebook, they're all data-driven companies, and this is giving them a big edge. But what does it really mean? It entails a lot of dimensions. But basically, Jim Barksdale, former CEO of Netscape, has really, I think, caught the essence of it, which is, if we have data, let's look at the data. And if all we have are opinions, then let's go with mine. And I might add to that, if you don't have data, that's no problem at all, because you can always start collecting or buying some. So really being data-driven means, in a nutshell, basing your decisions your business decisions, your strategic decisions on data rather than on feelings or opinions or something else. To give you an example, I might, actually we'll look at an example later, so let me hold back. I've just said you can always start collecting or generating some data, and in that regard, it's important to know that there's something called the data generating process, which is basically the process by which data is created and somehow landing or arriving in the database. And in that we distinguish between two forms of how we can create data. The one is human generated data, and the other one is machine generated data. And so human generated data is really anything that is created through the active action of a human being. We have today, every one of you has created quite some human generated data by filling in the form when you signed up for this webinar and by also filling in the survey. But it's also, emails, posts that we do, SMS. If you just enter data manually, let's say your sales data in an Excel sheet, this is all human generated data. Whereas machine generated data is everything that is produced by machines without significant input from humans. So this is what we talked about before. For instance, the data logging devices, the sensors, barcode scans, and video surveillance cameras. And if I now chucked in this audio file and got a transcript, this is also machine generated data. This is just for you to know that, because I hear the question a lot, okay, but how can I start collecting data? You need to first distinguish between these two types of how you can collect data. In both cases, this is also a mindset shift. If you want to become data driven, you must regard data as an asset, and you must regard it as an asset that must be invested in. Whether it's machine generated data or human generated data, you need to invest either time or money to collect these data sets by setting up the right processes, by restructuring your processes, or by maybe even simply buying data. But data, once you consider it as an asset, has a lot of advantages compared to other assets that you might have. For instance, your HR or your inventory assets or your real estate assets. Because data assets can be used continuously, right? They are non-depletable. They're also non-degrading, so they're not decreasing in value. They have zero running costs apart from, maybe paying for a database. And they always will remain in the possession of your company, right? This mindset that data should be regarded as an asset is basically the mindset that the big companies have applied. This is why Google is giving out their services for free, because they want to collect data assets. This is why Microsoft has bought GitHub. This is why Facebook has bought WhatsApp. They're not creating directly any money from that, but they're continuing to accumulate huge data assets, which give them a competitive edge. So when you want to embrace data, you must make this mind switch of, okay, it's valuable, and I also have to invest in it. And whether it's machine generated or human generated data, there are many ways to start collecting data. You have, ways to get internal data, which could simply be tracking everything you do. So you could start by tracking your work time. You could start by tracking your customer interactions. When did you interact with whom? What did you say? You could start tracking the tasks you have, how much time you spend on a task and who is working on this task. Most of you will already have a website. So there's a lot of internal website data you can draw from that. You might set up new touch points with your customers. So you might give them a call once every now and then. You might want to conduct surveys like we did today, or you might simply restructure your processes, your business processes, to start collecting internal data. For instance, by setting up such a form as we have today for this webinar. Let's say if a customer wants to get in touch with you, you might want to force this customer to first filling in this form, and then giving out your number to that customer to call you. Yeah, so there's many other ways you can start collecting data within your company. But basically the idea is to track things. There's also external data sources. There's a lot of data on the web, and you can simply get all of this information, which is called web scraping. Many companies like Instagram, for example, also offer what is called APIs. That's which is the acronym for Application Programming Interface. So you can get you can get the data of all Instagram profiles that are public by programming a machine, and you can literally get millions of Instagram data, for instance, with such an API. There's also a lot of data out from public authorities, such as population data, and there's many tools that you can use to buy basically data or buy data sets directly. For example, I have a tool which is tracking my Google rankings for certain keywords every 6 hours. And so I can track how am I, for instance, ranking on Google for the keyword webinar on data science. And to give an example of what data-driven decision-making means in practice, this is the book we have created, we have written, and everything we did with this book, you see this small cover, but everything that's in there is data-driven. For example, the design was data-driven design. We had a couple of designs created, but then we conducted a survey to determine what image best conveys the level of the book and is most aesthetic to our specific target group. We also did data-driven naming. So we made a keyword analysis on Google and Amazon to determine what keywords are mostly looked at. You know, we could have also said, hey, I like the title, the best data book out there. Or we could have also said, hey, I like this design and this design. But our opinions are irrelevant. The point is to base your decisions on data. It continues. We did data-driven marketing. So we included a forward by an influencer, and we chose the influencer which has the highest number of followers in the European market, which is our target market. We also did a data-driven competitor analysis and to check what books exist already, how similar are they to our book, and how often do they sell. And let's go to the next slide. We also did data-driven pricing, right? Because if you have a book, then how much do you charge for it? We could have just said, hey, because we had these discussions internally among the 3 authors, I think 30 is a good price, but then one author said, no, I'm not going to buy any book that's more than 10 euros. And then the third one said, but 10 euros is really not showing the value of this book. And I think we should price it at 60 euros. And non-data-driven decision-making would mean discussing with opinions and then going with something. Data-driven decision meant in this case, okay, let's ask our target group. We asked 100 people, did a survey, and asked them how much would they at most be willing to pay for this book, for the ebook version, for the print version. And these are the actual results, which is, if you're a statistician, it's beautiful because it's a bell shape. But we took this data to then say, okay, we're going to price the book at XYZ because we want to get this number of sales. So this is what data-driven decision-making means. And the main takeaway that I want you to take away from today is when we look at the summary, we learned what digital transformation is. Okay. We learned that data and big data are the main drivers of digital transformation today. But really the most important keyword, the most important takeaway that I want everyone to take away is try to think data. Try to shift your mindset towards a data-driven thinking. Don't say, hey, I think we should do marketing with this image. Try to have a small survey and validate that this is true. Try to have every decision you make based on some sort of data. And if you don't have data, try to collect some. And if you can collect some, then try to have at least estimates of it in every decision you take. Good. I've talked a lot now. I hope that for most of you, because I also just had a look at the data before we started, I think most of you had no or little knowledge about most of these topics. So I hope this level was appropriate. This was a very gentle and easy start, and we're going to become a bit more technical in the coming sessions. And yeah, that concludes the first part of the webinar series. Next week, we're going to be looking at how specifically data can be used with data analytics. I hope to see a lot of people there, but I will open the floor for questions now. So thanks everyone for listening so far.
Thank you so much, Michael. I believe everyone found this very useful. And yes, there might be some questions you have about what is AI, what is machine learning, and maybe more specific questions about big data or data analytics. This will be covered, I believe, in the coming webinars, as Michael has mentioned. So I'm going to pose to you a couple of questions that the women entrepreneurs have put into group chat. So I think this is more sector specific. How can digital transformation be useful in the fashion industry or agribusiness and maybe even tourism?
Okay.
Yes, so could you cite some examples so they can see the relevance perhaps?
Okay, can you repeat the sectors again? I need to write them down.
Yeah, so I think the four, I mean, the three non-IT sectors that we work with, that will be agribusiness, tourism, and textile and apparel. So more like the fashion industry.
Okay.
Yes.
Okay. So agribusiness, I have a lot of use cases, and we have a lot of examples that we're going to look at over the course of this webinar series. But in the agribusiness, there's obviously, predictions of pricing if you're a farmer. So what is the optimal point to sell your goods? There's also a lot of predictions you can use to see what kind of crop you should harvest based on maybe data you have about what you've grown in the past. I'm not an expert in agriculture, but there is differences depending on what you grew, what you can grow next, I guess. You can make use of all sorts of weather data maybe in the agricultural sector. And yeah, I can't think of more examples.
I think I could also add you in the AI and image processing.
Yeah.
They could also take a picture, let's say, of a leaf, right? For example, and it could identify what kind of disease that plant has.
Yes, yes.
Something like this that is related to AI. I must also add that I started to take some courses on AI after attending some of Michael's mentoring sessions with the IT sector. So that's how I learned about some examples. What about fashion tech? Do you have some examples? I have one to give, but I'll wait for you to share any one that you might have.
Yeah. So I have worked in many industries. To be honest, fashion is one that I have not worked in yet. And in general, I always say that data can really be used everywhere. Right now in the fashion industry, I guess the thing I could think of most of is in the area of digital marketing, right? Because fashion is a lot about targeting the right customer with the products that you create as a fashion designer or fashion creator. And in the area of digital marketing and really targeting, tailoring your message, your image to that person is really important. For instance, there's a thing called A/B testing, where basically the idea is that, let's say you have a newsletter or let's say you have a marketing campaign, and A/B testing would mean I have image one and I'm going to try it out for 2 days. If I post this on my website, how many people react to this and find it good and click on a button? And then I try a different image for 2 days and see, okay, how many people reacted to it? And the idea of A/B testing is to test out different setups for your marketing message, for your image, for when you send out an email, and see which setup works best and helps me achieve most sales or most engagement.
I think also to add on to what you've mentioned, something that is relevant to everyone is chatbots, right? You can go to fashion websites sometimes, and instead of just having a front person, you can just talk to the chatbot what you're looking for. I'm looking for shirts and skirts, and I think this applies to all businesses, not just the fashion tech.
Right. Yeah. That's also another one. Yes.
And another. Yeah. Sorry, Michael. Please.
Yeah. Just we are going to look at many more examples in the over the course of this webinar series. So I know I opened a box today, but I promise we'll close this box and we'll look at many examples in every industry.
Yes, definitely. Thank you so much, Michael. Well, we do have a few other questions. I hope you don't mind taking them.
Yeah, sure.
Yeah, I think, could you maybe, this is my personal question, and I think maybe we could just clarify for everyone the difference between digitization and digitalisation, because I think this is always often confused and they are always used interchangeably, but they are very different concepts.
Mm-hmm. Yeah, so really, in order to do digitalization, you must digitize first. And digitizing simply means turning analog into digital. So, for example, the fact that we have digitized text in forms of email or in forms of WhatsApp messages, rather than writing letters or pen and paper. This is the digitization. And what it has enabled is to digitalize the process how we communicate, right? I send you a voice message or simply a text through WhatsApp rather than having to call you or rather than having to send a letter. I can send you my working contract through email rather than having to go to the post office. And so this really, the way we restructure processes, which is enabled through the digitization of information. And this is what is called digitalisation. I know it's confusing.
Yeah, and I think for many women-owned businesses, especially for part of the SheTrades network, some of us, for example, maybe you're in tourism and you're still registering or registering information on a piece of paper or a logbook, and the goal to digitize is to move from a physical paper to computerize everything. And then, yeah, I think that's important in understanding this, how it's linked to digital transformation. So another question I have is, someone asked who manages the data space and how can I be sure that data in the cloud doesn't get wiped out? Yeah,
it's a good question. So the data space is a decentralized world. Okay, we don't have a central unit where all of the data is stored. The internet is basically that, right? Because I have my data stored on a certain server, and then your data is stored on a different server. And so because it's decentralized, there's really very little danger that we lose information. Because if one server or if one data center of Google is breaking down, then there's all the other data centers. That's one. And the second one is if you use personally cloud services, for instance, cloud storage, all of these companies make sure to replicate data on different data centers at all times. So they always have backups. And even if a data center breaks down, which happens every now and then, usually no data gets lost because it's secured somewhere else as well.
perfect. Thank you so much, Michael. And another one, I mean, is there a measure to determine whether your data meets a standard quality requirements? Yeah.
Yeah, the data quality, how much data quality do you need? The answer is it depends, and it must be good enough. Good enough implies that you have a certain use you want to use it for. If you want to create, let's say, an AI system that is able to give a medical diagnosis, you'd want to have this system be very accurate. And so you need a very, very high data quality. If you simply want to create a dashboard that visualizes how many visitors you had on your website and some visitors are unrecorded, then this is obviously a less crucial process, and so your data quality does not have to have such high standards. So there's no one size fits all solution. It really depends on what you want to do with it.
So on the topic of cloud and data on the cloud,
Yes.
what would happen, let's say if you pay for cloud services and you have
Yes.
data on it, and what happens if you're no longer a paying customer, and what happens to the data?
This depends on what cloud service you use. The three big ones, which is Amazon AWS, Microsoft Microsoft Azure and the Google Cloud. They basically all have the same function that once you don't pay, your data is still being stored for about, I think, 90 days. And if you then reactivate paying, you'll get this data back, and it's completely wiped out of their servers after a certain period of time.
And to add on to that question, does one have, this is from Angela, does one have the rights to protect their data?
This depends on where you're at, but basically, that's a good question, by the way. Basically, what we have today is a world which is subject to what is called the Brussels effect. The Brussels effect means that because the European Union is the biggest economy in the world, it can set the rules for many things. And we've seen that, for instance, in the agricultural sector, there's certain standards that need to be met in terms of, I don't know, pesticides for certain produce. And because everyone wants to do business with the European Union, somehow the entire world ends up adopting these standards. And we have the same thing in the data world today. Because the European Union has issued a new policy, which is called GDPR, the General Directive on Data Protection, in 2018, which sets standards and which gives customers the right to have their data protected in a certain way. Now, this actually only applies to businesses that either do business in the European Union, but it also is applicable to businesses that do business outside of the European Union, but deal with data from European Union citizens. So in other words, if I, for instance, went to Japan and I give out my personal data when I sign into a hotel, this Japanese company would actually have to adhere to the GDPR and follow the rules of the European Union. Now, obviously, the European Union cannot enforce if there's an infringement in Japan unless this person comes to Japan. But the GDPR, because it applies to all European Union citizens who happen to be in the entire world, right? It's basically governing the world. So the GDPR is the most strict and most comprehensive set of regulations on laws we have out there that ensures that personal data is protected. But obviously, if you're now in Nigeria or if you're in Ghana or in Bangladesh, you have a different set of regulations that applies to you personally. And even if you somehow wanted to enforce the GDPR, you would have to come to the European Union. So it's a very complicated space, but it basically depends on your national laws. And you must respect the rules that apply to European Union citizens.
Thank you so much, Michael. Unfortunately, I mean, there are many interesting questions that are coming in and definitely relevant, but I think some of them are very sector specific. So I would kindly ask everyone to be patient because we will be moving forward with subsequent webinars where you start to see applications of machine learning, AI, and then on questions about how that could be applied to your particular sector or maybe your subsector. I think maybe you will see more applications-based things come in the data strategy, the fourth session or the last session, the fifth session. So I think we will maybe stop the questions if you don't mind, and we can call it a day. Apologies to those whose questions we can't answer. And we will do our best to have a longer Q&A session next time without stressing Michael. And for those who have not completed the questions, the poll, please do. There are 25 of you out there. I don't know who you are, but I will. So please fill them up, the poll. And well, very much thank you to Michael. It's been a fantastic session. We have 4 more sessions of this. And it will really benefit all of you to attend all of them to have quite a good foundation of the concept of AI, digital transformation, and so forth. And of course, I want to alert everyone that on the 31st of July, we have another session on terms of use for websites and applications. So some of the questions you ask about data on contracts, if people go to your website and your apps, what are some rules, about the use of your information and stuff like that, that will be applicable to you. And please sign up for that on Converf and Zoom. And so thank you very much, Michael. Thank you for having us. And I think we can see from the reviews from the SheTrades members that they really appreciate this session.
Yeah, thanks. I hope it was helpful for everyone. I hope to see many of you in the coming sessions. And yeah, if you have any specific questions, you can also reach out to me on LinkedIn. So thanks everyone for being here.
Yes, thank you, and reach out to Michael, and of course, consult his book if you need more specific information. So see you all next time. Yeah, you will have gotten the dates for the other 4 sessions in the email, and I will also be sending out reminders. So
Perfect.
thank you, everyone, and have a great Wednesday, I
Yes.
think. Yeah,
I'll see you. Thanks,
see
Edison.
you. Thank you.